Hello everyone, how to solve this problem for the values of x if we have x plus square root of x is equals to 56 and we solve this problem for the values of x. So here first we need to find the domain of this equation. After that we will find all the roots of this equation, and at the last we will be verify that which of the roots are solution of the given equation and which of the roots are extraneous root. Further, I can explain the difference between solution and extraneous root in this question. Okay, so please watch this video at the end. Now here first we move this x to the right hand side. It will be written as square root of x is equals to 56 minus x. Now here we need to find the domain of this problem. So for this, because we solve this problem for only real roots or real values of x, so for this the variable inside the square root is must be greater or equals to 0, and the right hand side is also must be greater or equals to 0. So from here you see that our x is less or equals to 56. And now when we compare both of these inequalities, you will get here 0 is less or equals to x is less or equals to 56. It means that this is the domain of the given question statement. So it means that our solution will be lies within this interval 0 to 56. And now we move towards to find that solutions of the given equation. So for this we need to copy down given question statement. Here the given question statement is x plus square root of x is equals to 56. So here I can just use the substitution technique to solve this problem. So that's why we will first substitute here square root of x is equals to y. So when you put square root of x is equals to y, and after substituting this, we will take scaling on both of the sides. And when we take scaling on both of the sides, then you will get here x is equals to y square. So in this question we put x is equals to y square and we put square root of x is equals to y. So after substituting the above values, we will be write our given question statement as x is equals to y square. This will becomes y square plus square root of x is equals to y, and this is equals to 56. And now we move this 56 into the left hand side, and it will be written as y square plus y minus 56 is equals to 0. So here after substituting we convert our given radical equation into the quadratic form, and you know about that there are three methods to solve the quadratic equation. First is factorization, second is completing square, and the third one is by using the quadratic formula. But here I can just use the factorization technique, so that we need to break its middle term. So we write our middle term y as in this form. This is y square plus 8y minus 7y minus 56 is equals to 0. And you see here 8 minus 7 becomes 1, and this is our plus y. So now here we need to take common y from first two values. So when you take common y from here, we will get y plus 8, and when we take common minus 7 from here, we will get y plus 8 is equals to 0. So further in the next step, you see here y plus 8 be the common term. So when you take common y plus 8, we will get here y minus 7 is equals to 0. So further in the next step, we divide this equation into the two cases. The first case is we write y plus 8 is equals to 0, and the second case is we write y minus 7 is equals to 0. So from here we easily get the value of y is equals to minus 8, and from here we easily get the value of y is equals to 7. So after that we need to move backward and we substitute the value of y here. So the value of y is square root of x. So when you replace the values of y here, it will become square root of x is equals to minus 8, and this will become square root of x is equals to 7. So after that for the values of x, we need to take scaling on both of the sides on both of these cases. So when you take scaling on this term, it will be written as this 2 and this square root are gone, and we will get here x is equals to minus 8 square equals to 64. And when we take scaling on this term, so it will be written as this 2 and this square root are gone, and we get here our x is equals to 7 square, and 7 square is equals to 49. So here we get the two roots of the given equation. One is 64 and second is 49. And now here in the next step we need to verify both of these roots, and we will be check that is both of the roots are solution or both of the roots are extraneous root. So for verification of the roots, we need to copy down given question statement here, and the given question statement is x plus square root of x is equals to 56. This is our given question statement, and here we substitute above two values of x and we check its behavior. So now here in this side we put the value of x is equal to 64 into the left hand side, and it will be written as 64 plus square root of 64 is equals to 56. And here you see that this is 64 plus square root of 64 becomes 8 is equals to 56. 64 plus 8 is equals to 72 equals to 56. So you see here both of the sides are not equal. So this means that the value of x is equals to 64 is not satisfied our given question statement. So this means that x is equal to 64 be the extraneous root of the given equation. So x is equal to 64 be the extraneous root, and now we move toward the second value of x. So the second value of x is 49. Now we put this value here and it will be written as 49 plus square root of 49 is equals to 56. And you see here we have this is 49 plus square root of 49 becomes 7 is equals to 56, and 49 plus 7 becomes 56 equals to 56. So this shows that the value of x is equals to 49 is satisfied our given question statement. So x is equals to 49 be the solution of the given equation. So here you see that the roots of the given equation that is satisfied our given question statement is called the solution of the given equation, and the roots that is not satisfied our given question statement is called the extraneous root of that equation. So these are the difference between solution and extraneous root, and this is the final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.